GED Land. Hey, Brian. I've met many of you before. Some of you, it's the first time I'm meeting you. It's a pleasure either way. Hey, Bilal, Luis, great to have all of you here with us tonight for what may very well be the toughest, or maybe the second toughest, of our math classes. Coordinate Plane Part 2, also right up there, but Algebra Part 2, definitely a contender for the hardest of our math sessions. Let's talk about what that means. First, I just told you that this is going to be difficult math. Is it reasonable to expect that 90 minutes from now you are going to be an expert in every one of these topics? No, it would be nice, but that's not a reasonable expectation. And having reasonable expectations is really important, right? When we have unreasonable expectations, that's when we often get frustrated, right? That's when we get mad, when we get angry. Why doesn't this make sense? Why do I not instantly understand everything? And it would be nice if that's the way the world worked, but of course it doesn't. So setting reasonable expectations for yourself, very important, because it's going to help you while you study. It's going to help you stay grounded, and it's going to help you keep your head in the game, right? You're not going to get mad and upset and want to quit. You're going to keep going. So let's talk about reasonable. Reasonable expectations for tonight is to have a basic understanding of most of the topics that we cover, right? That's really what you're hoping to get out of tonight. And then after tonight, you'll keep working on these topics. And after a lot of hard work, you will master them. You don't have to master them today, right? You just have to be good enough at them for test day. Hey, Nicole. Hey, Angela. What can you do if after tonight you want to review this class? What do you have access to that's a great way to review the classes? The videos, the pre-recorded versions, right? Each of these classes we offer about once a month. They cycle through. So this will come up again at some point in January. But I don't know about you. If I just learned something and I wasn't great at it, I wouldn't want another month to talk about it some more. You've got the videos. So on your home page, which looks something like this, right? Up here, this is where you click to see the live schedule. You got the intro video. But if you scroll down a little bit, that's where you'll find the video library. So you have 24/7 access to all of these videos. I clicked over on the math tab over here. That's why I see all the math videos. If you wanted to look at a different topic, you would just click a different category on the left side. And something else to note, the order of these videos is the recommended order in which you learn this stuff, right? So starting with number sense 1 and 2, then algebra 1 and 2, and so on. Number sense 1 and 2 really review a lot of things that come up in other sessions. And algebra 1, of course, introduces a lot of things that will help make algebra 2 make a lot more sense. So if you haven't done those 3 yet, we're not going to kick you out. I mean, Sasha's kind of mean, but she's not mean enough to kick anybody out of the classroom. I kid. Sasha's extremely nice. Right? She used to be a bouncer, but now she's extremely nice. But we're not going to kick anybody out. But if you find yourself getting a little bit lost and you haven't seen Algebra 1 yet, or you haven't been to Number Sense 1 yet, that might be part of the reason why you're a little bit lost. Right? The whole reason you're here is either because you never learned this stuff in school, or maybe you learned this stuff in school and it didn't stick, right? And that's why you're going back and doing your GED, right? So maybe you learned a long time ago, maybe you never learned it, but if you haven't done the prerequisite things, of course, it's going to be harder to understand what we talk about tonight. So if you haven't watched those, our recommendation is after tonight, go back and watch the videos you haven't watched, then go back and rewatch the Algebra 2 video. Okay? Also, way down at the bottom of this page, there's actually a link to all of the PDFs for all of the videos. So for example, if you've never seen Number Sense 1 before and you decide you want to watch the video, it would definitely help to have the PDF while you're watching it. If you scroll down to the very bottom, download the PDFs, you'll see there's a list for all of the PDFs of all of the different classes. And thank you very much, Teacher Sasha. Just put tonight's PDF into chat. I'm going to put that stuff away. Have any questions? For those of you who have been here with us before, where's the best place to ask questions during class? The whole reason we have two teachers is so you can ask questions and get answers in real time over in the Q&A. Yeah, as you've already seen, the regular webinar chat scrolls by very, very quickly. So the Q&A is definitely the best place for questions. If you haven't used Zoom very much and you're not sure where to find the Q&A, on your Zoom toolbar down at the bottom of the screen, right, there's a little button that says Q&A on it, or depending on how wide your screen is, if you don't see a button that says Q&A, you'll see where it says More, where there are 3 dots. Click there, that'll open up the rest of the menu. Then you can click on the Q&A. In fact, Q&A is so important that Sasha and I want to make sure that everybody has found it. So I'm going to ask you a question, and I want you to answer this question over in the Q&A. And this question is going to be essential to your GED studies. So here's the big question. Please answer over in the Q&A. What is your favorite winter activity? Okay, maybe it has nothing to do with the GED. What is your favorite winter activity? Let us know over in the Q&A. Sleeping, I'm on board with sleeping as a winter activity. Although that's kind of an all-year activity. But again, let us know over in the Q&A. What is your favorite winter activity? And if you're having trouble finding the Q&A, let us know. Some of you are answering the regular chat. Nope, don't want you to answer me in the regular chat. The whole purpose of this is to make sure everybody has found the Q&A window. Hot chocolate, Christmas windows, lots of hot chocolate, snow angels, snowmen, lots of hot chocolate, more snowmen, hot chocolate, staying in bed, going to the gym. Person who said going to the gym, you might be alone in that one. That is probably not going to be high on the list of popular topics. Sleeping, gaming, those are good activities. Wrapping gifts, drinking hot chocolate. Of course, it depends what climate you live in, right? Sasha's over in Michigan. I'm up in Toronto, up in Ontario. It's even pretty similar weather here to where Sasha is. We are indoor people during the winter. It's nice to go out. It's nice to go out skiing. It's nice to go out skating and things like that. But yeah, it's good indoor time. Skydiving. I used to skydive in my youth, but we didn't go skydiving very much during the winter. There were always issues going skydiving in the winter. Mostly, not that it was too cold, mostly runway issues. Planes had trouble taking off if there was too much snow, if it was ice. So that's why we did most of our skydiving in the warmer weather. But thank you very much for participating over in the Q&A. Questions about anything at all during class. Teacher Sasha loves to answer questions, so don't hesitate to reach out to her over in the Q&A. But now it is time to get into tonight's class. And here's a little breakdown of what we covered in Algebra 1 and what we're going to cover in Algebra 2. So in Algebra Part 1, you focused on translating word problems into math, on understanding how variables represent unknown values, and solving equations and inequalities. So we are not going to be focusing on those things tonight. Tonight we are leveling up to higher level difficulty algebra, to more advanced topics. Tonight we're going to focus on working with polynomials. We'll explain exactly what that means. We're going to talk about quadratics, something you might have never heard of, or maybe something you heard of and wish you'd never hear about again. And we're also going to talk about functions. Of the topics tonight, I think functions are actually the most fun, as crazy that might sound. Functions is one of those topics that if you don't understand it and you look at a function question, you have no idea what's going on. It has a very high psych out factor. But once you actually understand what a function is and how functions question work, they're actually not that bad at all. They're actually kind of enjoyable and relaxing compared to some of the other math that you're going to see on test day. But let's dive in. Our first topic, polynomials. So polynomials are mathematical expressions containing multiple algebraic terms. Remember, there's a difference between an expression and an equation. Equations always have equal signs in them. Expressions are typically just a bunch of number and letters hanging out, having a good time, but they don't actually equal anything. They don't have a lot of purpose. They're just hanging out together. And polynomials are expressions with multiple algebraic terms. For example, 3x squared plus 7y plus 8, right? That's got three different terms, 3x squared, 7y, 8. So that is a classic polynomial. Typically, it's going to have a variety of participants, a variety of different individuals hanging out, coefficients, variables, exponents, and constants. Okay, if we look at this one up here, let's take a look at this one up here. What up there are our coefficients? There's two coefficients in there. What are the coefficients? No worries. Welcome, Tadja. 3 and 7. Right? 3 and 7 are both coefficients. The coefficients are the numbers that love the variable so much, they give them a big hug. So that's what the coefficients are, the numbers hugging the variables. What are the variables in there? Yeah. X and Y. Those are our variables. What's the exponent in there? The 2. Yep. That thing there is the exponent. Now, there's actually another exponent, but it's hidden. It's what I've always considered the creepiest number in the world, because it's always there even when you can't see it. So there's also really an exponent of 1 on the y. It's just we kind of ignore 1 as an exponent. We don't bother writing it because it doesn't do anything, right? Anything to the exponent 1 is just itself. 3 to the 1 is 3. 7 to the 1 is 7. Y to the 1 is y. So the visible exponent, that's the one that we usually think about. And how about the constant? What's the constant in that expression? Yeah, the 8. Right? So constant is a number that's lonely. It doesn't have a variable for a friend. It's just hanging out all by itself. So polynomials don't have to have like just a square term, a regular term, and a constant. Polynomials come in a lot of different forms, but this is a fairly common one to see. Now, poly just means many, right? Poly is Greek for many. We also see the word poly in geometry, like polygons are many-sided shapes. Polynomial has multiple algebraic terms, and so we just went through all of that. If there's exactly 2 terms, it's called a binomial, right? Bi means 2. The bicentennial, that's the 200th anniversary, that kind of thing. So binomials have exactly 2 terms. That's a specific term. Polynomials, much more general term, right? Anything that's more than 1 term can be called a polynomial. But that's an example of a binomial. This one just has a variable and a constant, but it's got 2 different terms, so that's a binomial. Let's talk about doing math with polynomials. First, adding and subtracting. A fundamental rule of addition and subtraction, not just for polynomials, but for all math. A fundamental rule is you can only add and subtract identical things. You can only add and subtract like terms. For example, here's a question I bet you didn't expect to get today. What do you get when you add 1 zebra plus 2 zebras? You get 3 zebras. It's not a trick question, right? 1 of a zebra plus 2 more zebras is 3 zebras. How about if you tried to add 1 zebra and 2 giraffes? What would that give you? One zebra plus two giraffes. Yeah. Right? You can't add zebras and giraffes, maybe unless you're a mad scientist, right? Because they're different things. And that rule applies to everything in the universe, right? You can only add and subtract identical things. So when it comes to polynomials, that's exactly it, D, right? When you want to add or subtract things, you can only add or subtract them if they've got both the same variable and the same exponent, right? So x squared and x, those are different things. X squared and y squared, those are different things. You can only add or subtract when both the variable and the exponent are identical, right? So 9y squared, 9y to the 4, nope, those are unlike terms. They're not exactly the same. The coefficient doesn't have to be the same, right? We had one zebra and two zebras. The one and the two are allowed to be different. That's just how many of the things we have, right? So that's really what a coefficient is. How many of the things you have, right? It's the things that need to be identical. So when we add or subtract, we keep the thing the same, we keep the zebra the same, we keep the giraffe the same, we just add or subtract the coefficients, the number of each that we actually have. So if we look at this one here, right, first thing we notice is we've got identical things. They both have x squareds in them, and you can think of the x squareds as zebras if you wanted, right? You could think of this problem as 8 zebras minus 6 zebras. And if you have 8 zebras minus 6 zebras, you're going to end up with 2 zebras. Here, the zebra is just as an x squared, right, instead of a zebra. So things are interchangeable when it comes to math. It doesn't matter what the things are. And this is why a lot of people, once they understand math, maybe even start to enjoy it a little bit, because it's constant, right? Things stay the same. No matter how weird things look, the same rules apply over and over again. And sometimes on the GED, right, the difficulty is taking something that looks weird and turning it into something that looks normal so you know what to do. But whether it's a zebra or an x squared, if we have 8 of it and we're subtracting 6 of it, we're always going to be left with 2 of that thing. So that's basically how it's going to work. Okay? So adding and subtracting, you can only add and subtract like things. That's the big rule to remember. Let's talk about dividing polynomials. Okay? On the GED, it's unlikely, I'm not going to say it's never going to happen, but it's unlikely you're going to divide a polynomial by another polynomial, right? That would be a higher level difficulty question. On the other hand, dividing a polynomial by a monomial, mono just means one, right? That is something you might have to deal with. So let's say we had this, 4x squared minus 8y cubed divided by 2. First, we can only divide like things, right? So what we're going to do is look for the things on top that are similar to 2. What are the things on top that are similar to 2? The x squared and the y cubed, those aren't similar to 2. But what are things similar to 2? The 4 and the 8. Yeah, right? Those are numbers just like 2 is a number. So when you divide a polynomial by a number, you just divide the coefficients, right? Since we're dividing by a number, we're going to divide it into the number parts of the terms above. we can think of this as two different fractions, right? 4x squared minus 8y cubed divided by 2. You can actually take that minus sign and split it up into two separate fractions. 4x squared over 2 minus 8y cubed over 2. And now we can just divide the 2 into the coefficients on top. Right? We can just take that 2 in the first one. Hey, that goes into 4 twice. Take the 2 in the second one. That goes into 8 4 times. And we got rid of both 2's on the bottom. So now we just have 2x squared minus 4y cubed. So when you divide a polynomial by a number, it's only the coefficients that are potentially going to change, right? Not going to have any impact at all on the variables. When you divide a polynomial by a variable, you can only simplify terms that have the same variable by which you are dividing. So this time, let's say, we had 4x squared minus 8y cubed divided by x, right? This time, instead of dividing by 2, we're dividing by x. First step is the same as before, right? We had that minus sign on top, and I use that to split it up into two different fractions. 4x squared divided by x, 8y cubed divided by x. And the only term we're going to change is the term that's got double x's. It's got x's on the top and the bottom. If you have x squared, right? If you have x squared divided by just plain old x, when you cancel out the x on the bottom, what's the x squared going to turn into? What's x squared divided by x? It's not 1, just x. Yeah. Right? If you were to do x squared divided by x, remember x squared is just x times x. And if you have x times x divided by x, you can cancel out one of the x's on top, and you're going to end up with just plain old x, or x over 1, if you prefer. So that's what happened over here. Right over here, the x on the bottom disappears, and the x squared on top changes to x. Can we cancel anything out in that second term? No, we've got a y and an x, can't do anything with those different variables. So that's going to be our final answer, right? 4x for the first term minus the entire second term, because there was nothing we could do with it. So if you're dividing by a number, you might be able to simplify the coefficients. If you're dividing by a variable, you might be able to simplify the variables, right? Different things stay different when you're doing mathematics. Nice job on that. Now, let's get a little bit more practice with this. If it's a more complex polynomial division, look for factors and variables that things have in common with the divisor. And the divisor is the denominator, right? The divisor is the thing on the bottom. So this is an example of, again, this would be a much harder question. We're not just dividing by a constant. We're not just dividing by a variable. Right? We're dividing by a combination of constant and variable. So first thing we're going to do, just like before, is break it apart so our brains don't explode. So just like before, let's use that plus sign on top to split it up into two different fractions. Always allowed to do that, right? Just like if they gave us this, because they've got the same denominator, if they gave you that, you could always turn it into that if for some reason you wanted to do so, right? But that's the first thing we're going to do is split it up. And now for each of the two terms, right, we're going to treat each piece differently. The numbers, the x's, and the y's. And we're going to see what we can simplify. So let's start with the numbers in each term. Let's start with the first fraction. We've got an 8 and a 6. What are 8 and 6 both divisible by? 2. Yep. So we could divide each of those by 2. And that would become a 4. And that would become a 3. How about in the second? What's going to happen to the 6 on top and the 6 on the bottom? What happens when you have 6 divided by 6? Yeah, they completely disappear. Technically, they both change into 1s, but like I said, 1 kind of creepy, kind of lonely, because it doesn't really get a lot of attention. So technically, we change each of those into a 1, but when we rewrite it, right, when we rewrite it, we're not going to, you could write the 1, but you don't have to write the 1. That's up to you. Okay, next up, let's simplify the x terms next. So in the fraction on the left, we've got an x to the 4 and an x to the 2. Now, in your number property classes, you learned the division rule for exponents. Right? When you have, let's pick a different letter. If we had z to the 7 divided by z to the 4, what's the rule for dividing exponents? What do you do with the powers when you divide? Very nice, Erica. This rule tells us we subtract the exponents. So 7 minus 3, sorry, 7 minus 4. So what would our final exponent be? Z to the 3. And again, this is covered in our number properties classes. I mentioned at the beginning of class, if you haven't been to number properties 1 and 2, and you haven't been to algebra 1, a lot of what we cover today is going to be a giant mystery for you. Right? Algebra part 2 makes sense to do algebra part 1 first. Okay? So going back to our actual problem, if we have x to the 4 divided by x to the 2, what's going to be our new exponent on top when we apply that rule? Yeah, it's going to be 4 minus 2. So the x squared on the bottom is going to completely disappear, and we're going to end up with an x squared on top instead of x to the 4. Let's look at the second fraction. X squared divided by x squared. Well, what's anything divided by itself? Just 1, right? So yep. So those are just going to completely cancel out in that term. So after we deal with the x's, right, we're going to have 4x squared y over 3y. We wrote the 1s, but typically we ignore the 1s, over y cubed divided by y. Right, the x squareds completely disappeared over there. Great. One more thing to deal with, and that is the y's. So let's start with the fraction on the left. Y divided by y. What's going to happen to the y's? They're going to disappear, right? Y divided by y is just going to be a 1. Basically, they're just going to cancel each other out entirely. And y cubed divided by y, if we apply that rule that we just talked about, and remember that's really y to the 1 down there, what's y cubed divided by y to the 1? Y to the 3 minus 1, you subtract the exponents, so that's just going to give us a y squared up there. So at the end of the day, we would get 4x squared over 3 plus y squared. That's all that's left after we do our division. Now, if you're thinking, wow, that was complicated, and wow, that was a lot of work, we're not going to disagree with you about that. We're not going to disagree that dividing polynomials by other polynomials can be quite confusing and time-consuming. And that's something you want to be thinking about during your test. If you saw this question on test day, is there a law that says you have to spend time on this question? No. On test day, if you see a question that looks really hard and time-consuming, what are you always allowed to do? Skip it. Yep, don't do it. Just don't do it. Spend your time on other questions instead. Any penalties for wrong answers on the GED? No. So if you are going to skip a question, what should you always do? Choose to skip a question, what should you always do? So you can go back to it, but well before you go back to it, what should you do? As soon as you decide to skip it, what should you do? Because there's no penalty for wrong answers. Don't leave it blank. No, you should always guess. You should never leave a question blank. You should always guess on a question, right? Don't try it. Somebody's saying, oh, if it looks really hard, I should try it. No, that's not a good way to pass the GED. Spending your time on questions that look really hard and you're not sure how to do is a bad decision, right? Spending your time on the questions you know how to do, that's a good decision, right? Every question is worth exactly the same during the exam, no matter how quick or long it is, no matter how easy or hard it is. You can flag it, you can go back to it, but you should always at least guess, right? You get a free guess on the GED. It costs you nothing to click one of those bubbles, so just make a guess and then spend your time on other questions. And you can flag it and you can go back to it later on, right, if you have time, but never leave anything blank. That guarantees you get it wrong. If you guess, at least you got a 1 in 4 chance on most questions of getting it right. Now, we just went through this in depth together. Let's give you one to do on your own, applying those same concepts. Right? Not gonna lie, these are some tricky questions. First, we're going to test addition and subtraction. So the poll is live. No spoilers in chat, please. A friendly reminder, no spoilers in chat, please. We want everybody to have the opportunity to work through the question together. And we always give people time to work on it together, right? To work on it alone before we come back and review it. So we're keeping an eye on the poll. We can see how many people have voted. And once we hit a certain threshold of people voting, then we'll come back and talk about it together. So let's go back and talk about question number 1. Okay, so we're being asked to simplify this expression. What was the big rule we talked about for adding and subtracting things? What has to happen before you can add or subtract? Right? Somebody just said this in private, but exactly, Ash, exactly, private chatter. You can only combine identical things. You can add zebras, you can add giraffes, you can't add zebras and giraffes. The things have to be the same. So that's the first thing we always want to do. Okay, we've got an a squared b. Oh, there's another a squared b. We've got an ab. There's another ab. So the a squared b's are my zebras, and the ab's are my giraffes. I can only add like things. So we've got 3 plus 3 of something. That's going to be 6 of that thing, regardless of what that thing is. We've got 4 plus 5 of something. Doesn't matter what the thing is. If you have 4 of something plus 5 of the same thing, you get 9 of that thing. So that's all we got to do. 6a squared b plus 9ab. That is answer choice D. Yep, apples and bananas, zebras and giraffes, however you want to think about it. You can only add identical things together. I just think zebras and giraffes are more fun than apples and bananas. So there we go. Nice job on question number 1. If you got it right, fantastic. If you got it wrong, as long as you understand why you got it wrong, as long as you now understand how to get the right answer, you've learned something important. Your test day score just potentially went up because you learned how to tackle this question. These are pretty complicated, so we're going to do a couple of these. Let's give you another one to do. Question number 2. The poll is live again. Apply what we... Always important to read the question carefully. When simplified, how many terms are in the polynomial? So you're not actually being asked to simplify it, right? You're being asked, if you did simplify it, how many terms are there? Basically, what we're being asked to count is how many different terms do we have, right? Any terms that are the same after simplification, those terms are going to combine. They're going to mash up into one term. And that's why it says when simplified. So that's what we really need to do. See how many unique terms there are. So let's do that. Right? J squared minus 2j squared. After simplification, those are going to be the same term. Those are going to combine into one. K cubed and 5k cubed. Again, after simplification, 1k cubed plus 5k cubed, that's just going to turn into one term. And then all that's left is the lonely 2j cubed. J cubed, that's unique. We didn't have any other j cubed so far. So that's going to be our third different term. So we're going to have a j squared term, a k cubed term, and a j cubed term. That means there are 3 different terms. Really, this is a do you understand the concepts question, as opposed to a can you do a bunch of math question. And you'll see both of those on test day. Sometimes you'll have to do math. Other times, if you understand the concepts, you'll get the point by avoiding doing the math. And that's what you want to do, of course, whenever you can. As always, if you have follow-up questions, Teacher Sasha, eagerly awaiting those questions over in the Q&A. So if you're still not sure why B is the right answer, then definitely reach out to her. But let's do one more related question. Then we'll move on to our next topic. In question number 3, you're really being tested on 2 things. First, adding and subtracting polynomials. So that's going to be a part of it, making sure we only add or subtract the like terms. The other thing you're being tested on is distributing a negative sign. We talk about this in our number properties classes, right? This is where you got to be really careful when you've got a negative sign in front of the parentheses. You've got to make sure you apply it to all 3 terms. And what's going to end up happening when we're subtracting a negative? it turns it into a positive. So that's where you got to be really careful with this one. Right? So you can think of multiplying by -1 if that makes it easier for you to do. Right? So that's going to give us minus 3x squared, a negative times a positive, plus 3x, because it's a negative times a negative, plus 2, because it's a negative, times a negative. So that's really the tricky part of this one, is distributing that negative sign properly. And then, of course, you got to make sure you're just combining the like terms. So we've got 5x squared minus 3x squared, minus 2x plus 3x, and plus 1 plus 2. Right? So a lot of people like to rearrange it to have the like terms side by side. And you don't necessarily have to put parentheses around everything. But 5x squared minus 3x squared, 2x squared, minus 2x plus 3x is plus 1x. Plus 1 plus 2 gives you your plus 3. So 2x squared plus x plus 3, and that's answer choice C. Okay, if you picked B or D, it might have been a problem with distributing that negative sign that ended up getting you. But nice work on working with polynomials. Next, let's talk about multiply, something we haven't talked about yet. And if you do need to multiply nomials of any kind, it's going to be binomials. It's going to be when you've got two terms. So when you're multiplying binomials, and now we're getting into the exciting world of quadratics, you apply FOIL. Anybody learn FOIL back in the day? Anybody remember what FOIL stands for? If you didn't, that is perfectly okay. But if you did learn FOIL once upon a time, and you remember what it stands for, let us know. Very nice, Roland. Right, Debbie? First, outer, inner, last. Nice, Sarah. Yep, that's it. Exactly, Megan, Chelsea. So first, outer, inner, last. That's what FOIL stands for. Yeah, it's all, we read fluent typo, Chelsea. No worries. We are used to it. So FOIL is just a mnemonic to help you remember and make sure you don't miss anything. And this is what we mean by multiplying binomials, right? 2x plus 3y, that's got two terms. That's a binomial. X minus 5, that's got two terms. That's a binomial. And FOIL just makes sure you distribute everything properly and don't make any mistakes. So the F in FOIL, we multiply the first terms together. So 2x times x, 2x squared. We multiply the outer terms together. 2x times negative 5 minus 10x. We multiply the inner terms together. Plus 3 times x plus 3x. And then we multiply the last terms together. Plus 3 times minus 5 minus 15. And then there's always one final step. Mathematicians are simple folk. They really like things to be as simplified as possible. So what are we going to combine together as our final step? The x's. Yeah, we've got two different x terms. So we are going to combine the minus 10x and the plus 3x. And then that's how we got that minus 7x in the middle. So those two things, the factored form in brackets, the expanded form, they're the same thing. They just look very different, right? Those are identical. One is in factored form, one is in expanded form. Let's give you an opportunity to practice this on your own. Okay? I'm going to give you a question testing you on this. question number 4, and I will put FOIL up on the board in just a moment. But go ahead, there's your poll, question number 4. And again, please don't put the answers into chat ever. Right? We're going to work through these together. The answer doesn't matter. It's the process that matters. And that's what we really want you to focus on. It's all good. We appreciate the enthusiasm. So which of the following expressions is equivalent to 3x plus 8 times x plus 2? Great, let's apply FOIL. Right, looking at the answers, we see we've been asked to expand it. So we do the first terms. That's going to give us 3x squared. As an aside, as soon as you see it's going to start with 3x squared, if you were inclined to do so, what answer could you already eliminate at this point? A and D. Yep. Right? Only B and C start with that 3x squared. So if the test were about to end, if you were about to run out of time, just by doing that first part, you got a 50-50 shot at getting this one right. Right? So 3x times x, that's 3x squared. Then the outer terms, 3x times 2, 6x. The inner terms, 8 times x, 8x. And the last terms, 8 times 2, 16. As always, we're going to combine like terms. So if we have 6x plus 8x, that's going to give us 14x as our middle term. And that means that B is the right answer to the question. Right? So FOIL, if you're ever given two binomials in parentheses and you need to multiply them together, FOIL is a great way to make sure you don't miss anything along the way. Now, expanding quadratics, multiplying by binomials, not that high level difficulty, right? If you know how to do it and you're careful and you follow the steps, not that bad. Much more difficult is when they give you something that looks like this and they want an answer that looks like that, right? Unpacking the parentheses, not so bad. Packing things back into the parentheses, that's actually a lot more difficult. But let's talk about that next. Let's talk about factoring quadratics. And that's really what we ended up with there. We ended up with a quadratic. So a quadratic typically has a squared term, a linear term, right, an exponent of 1, and a constant. That's what a quadratic typically has, a square, a linear, and a constant. If they just give you this part, it's a quadratic expression. If they set it equal to 0, then it's a quadratic equation. Remember, expressions, terms hanging out together. Equations, you actually need an equal sign for it to be an equation. If you ever need to solve a quadratic equation, you're going to do it by factoring the left side, right? You're going to put it into those parentheses, like we started with on the last one. So let's use an actual one so this makes more sense. First, right, we're going to look for numbers, right? We know that the last two numbers, the numbers at the end of each parenthesis, are going to multiply to this number here, right? That was the last in FOIL, right? Gave us that number by multiplying the two numbers together. So we're looking for two numbers that multiply to -50. Now, one of the nice things about the GED is almost always it's going to be integers, right? We don't have to worry about like, oh, what about a half and -30? No, we don't have to worry about that on the GED. But there's a whole bunch of numbers that multiply out to -15. And to find them all, it might be helpful to do a t-chart, right? If you ever want to find all the factor pairs of a number, a t-chart is a very efficient way to do so. Start with 1, right? Anything times 1 equals itself. So you can always start with 1 and the number itself. Okay. Other than 1 and 15, what else is 15 divided by? 3. And because it's negative 15, right, we would do 3 and negative 5. So that's another factor pair. Let's ignore the negative sign momentarily. 1 times 15, 3 times 5. Any other pair of integers multiply to 15? Nope, those are the only ones, right? We've got the 1 and the 15. We've got the 3 and the 5. But as Daksha says, right, we did a positive 1 and a negative 15. We did a positive 3 and a negative 5. We got to remember that we're allowed to flip-flop those, right? We're allowed to move the negative sign from the right column over to the left column. So there's 2 more potential pairs, negative 1 and positive 15, and negative 3 and positive 5. Right? So those are the only 4 pairs of integers that multiply out to negative 15. So we know that when we write it out in factored form, when we write it out with the parentheses, Jenny, so 3 times 5 is at negative 15, right? I just focused on the positive, right? Let's ignore the negative sign temporarily, because I don't know about you, negative signs hurt my head. It's easier just to start with the positive 15, right? What are the numbers that multiply to positive 15? And I just use my times tables, right? It's really, really good to know your basic times tables for the GED. Basically, you want to know up to 12 times 12, right? If you know your times tables up to 12 times 12, your life is going to be a lot easier on test day. Okay, so there's our 4 different pairs. But only one of those pairs is actually going to work. And the way we're going to figure out which pair actually works, we were just focused on the negative 15. Now we're going to shift our focus to the middle term. Right? We know we're going to end up with plus 2x's. So looking at our pairs of numbers, what's the only pair that when you add them together, you get positive 2? Yeah, the only ones that are going to give us positive 2 are negative 3 and positive 5. What happens when you add up 3 and negative 5? What do you get? We were to add 3 and negative 5. Yeah, that adds up to negative 2, but it's a plus 2 up there. Since it's plus 2, we need negative 3 and positive 5. If that had said negative 2 instead, then we would have picked 3 and negative 5, because those two add up to negative 2. So the 2 numbers you pick have to multiply to that term, and they've got to add up to that thing in the middle. Multiply to that and add up to that. So that's the only pair of numbers that works. Finally, let's just take a look up here. It's just plain old x squared. And on the GED, the vast majority of the time, it's just going to be plain old x squared. Since it's just plain old x squared, what's going to go at the front of each of our parentheses? Just x. Yeah, it's just going to be x times x. Right? So x minus 3 times x plus 5, that's what we sometimes call reverse FOIL, right? That's going to be the factors. That's going to be what gives us that particular number. Okay? Now, if you were unsure, right? If you were unsure, I'm not 100% confident, you could always just FOIL it back out. Right? You could always just say, okay, x times x, that's x squared, minus 3 times x, minus 3x, plus 5 times x, plus 5x. Minus 3 times plus 5, minus 15, right? So if I had FOILed it out, x squared minus 3x plus 5x minus 15, and sure enough, minus 3x plus 5x does equal 2x. So yep, I can always just kind of reverse engineer it to figure out I was correct, right? I did end up back where I wanted to be at the end of the day. Okay, so these are pretty complicated, right? These are pretty hard. Again, they might be good candidates for skipping. If you're not 100% confident, that's just what I just did up there. If you're not 100% confident, you can practice this, right? Keep practicing until you're sure you've got it down. And you can always choose to skip them on testing. Let's give you one to practice on your own. And remember, Teacher Sasha, eagerly awaiting your questions over in the Q&A. But let's give you one to do. Question number 5. Have fun. Just do a whole bunch of math. Let's talk about that. Let's talk about how you can be a strategist and save yourself time. First, let's just show you how to do this question mathematically. Right? Let's just show you the pure, okay, we just learned reverse FOIL. How would we do it? Okay, we want pairs of numbers that multiply to 16. So that would be my T-chart, 1, 16, 2, 8, 4, and 4. Now, technically, it could be -1, -16, -2, 8, -4, -4. But why in this case is it 100% safe to avoid the negatives? What tells us we can ignore the negatives? The answer is Ash. The answer choices can be your best friends on a multiple choice test. People who ignore the answer choices often end up doing a lot of extra work that they didn't need to do. So just peeking at the answer choices and seeing that they're all positive numbers means we can ignore the negatives, because that's definitely not going to be one of the answers. So it's going to be one of these 3 pairs. We said the numbers have to multiply to 16. In this quadratic, what do the numbers have to add up to? You've got to add up to 10, because that's the middle number. So out of the 3 pairs, what's the only pair that also adds up to 10? 2 and 8. Yep. So it's got to be the one that's got 2 and 8 in the parentheses. And that's answer choice B. So that's definitely one way you could have done this question. The other way you could have done this question, and it might have turned out to be a lot quicker, is just to work directly with the answer choices. Right? FOIL is much quicker than reverse FOIL in most cases. It's much quicker to expand than to contract when dealing with quadratics. So another thing you could have done is just looked at the answer choices directly. Right? You could have just said, okay, the answers have to multiply to 16. 4 and 4 multiplies to 16. 2 and 8 multiplies to 16. Nope. Nope. Already C and D have both been eliminated. Okay, what's the next thing I remember? I also remember the numbers have to add up to 10. 4 and 4 don't add up to 10. 2 and 8 do add up to 10. I don't know about you, but that seemed like a lot less work. That seemed like a lot less math. We're applying the same concepts, but we're using our best friends, the answer choices, to reduce the amount of math we actually need to do. Now, most people don't think this way, right? Most people remember back to when they learned math in school. They remember back to when their math teachers told them, if you want to get 10 out of 10 on this quiz, you've got to show your work. You've got to show me all your scratch work to get your full score. On the GED, did they give you any points for your scratch work? No. If you click the right answer, you get the point. If you don't click the right answer, you don't get the point. There is no in between. You either click it and get it, or you don't click it and you don't get it, right? So sometimes there are quicker approaches other than just traditional math. Sure, Carlos, happy to review that second approach again. Basically, I just looked at the quadratic, and instead of doing this t-chart, right? Okay, same first step. The numbers have to multiply to 16. Kamarla, it's the same in both places. Same in both places. All that matters is clicking the right answer. They never look at your scratch work. So same first step, I want two numbers to multiply to 16. One option is to create the t-chart. The other option is to look at the answer choices. All right, so 4 times 4 is 16. 2 times 8 is 16. 4 times 6 is not 16. 10 times 16 is not 16, so I can get rid of both of those. Next thing I looked at, they've got to add up to 10. We've got plus 10x, so they've got to add up to 10. And 4 plus 4 is not 10, right? 4 plus 4 is 8. That gets rid of that one. 2 plus 8 is 10. Yep, it multiplied to the right thing. It added to the right thing. So I know that B is correct. So not always, not on every question, but often working with the answers can help save you some time. Nice job on number 5. One more quadratic topic to talk about, and that's actually solving quadratics. We've done all the hard work, right? We've done all the hard work. Once you got to the point that we just got to, actually solving the quadratic, that's not so bad at all. So let's say we get x squared plus 2x minus 15 equals 0, the same one that we looked at before. This time it's a quadratic equation. It's set equal to 0. And like I said, this is the exact same one we did before, right? So we factored it to x plus 5 and x minus 3. The two numbers multiplied to negative 15 and added up to plus 2. Same one we did before, we ended up with plus 5 and minus 3. Okay, to actually solve for the values of x, we are going to apply a very basic principle of math. If a times b equals 0, what do we know is true? What's the only way to get a product of 0? What's the only way two things can multiply to 0? And that's a times, not an x. If a times b equals 0, what do we know? One of them has to be 0. Right? The only way to get a product of 0 is to multiply by 0. Right? When two values equal 0, when you multiply them together, at least one of the two must be 0. Right? If it's just a times b equals 0, either a is 0 or b is 0. If it's that thing times that thing equals 0, then either x plus 5 equals 0 or x minus 3 equals 0. Right? Either x plus 5 equals 0 or x minus 3 equals 0. So if x plus 5 equals 0, x would be negative 5. If x minus 3 equals 0, then x would be positive 3. So x could be negative 5 or positive 3. Those are the solutions. Sometimes they're called the roots of this potential quadratic. Okay, so that's how you're actually going to solve it. The reverse FOIL, that's the tricky part. The tricky part is getting to here. Once you've got to there, either that equals 0 or that equals 0. So you just solve both. Okay? Something to remember, sometimes you'll be asked just to write out the factored quadratic. Sometimes you'll actually be asked to solve it, and then you've got to do this extra step. There is a question in the PDF, question number 6, but we're actually going to skip over question number 6 because we still have one more topic to cover, and I want to make sure we don't shortchange functions. So question number 6, we're going to assign that one for homework. We are going to jump to our final topic of the day, which is functions. And functions are rules. Functions, I think of functions as machines. Functions are machines that take an input, grind them up into the machine, through the machine, and turn them into an output. So that's what a function really is. Let's break it down. Okay, let's break functions down. And this is just an example, right? So if we look at this fairly complicated example, the input is what's up here, 1 scarf, 2 scarf, 3 scarf, 4 scarf. And then the cost per scarf, that's the output. And the function that would be the rule that gets you from that thing to that thing, right? That's what the function would be. But let's break it down. Let's not just look at that. That's pretty confusing, I admit. Let's talk our way through a function. So this is what functions look like when they're presented mathematically. And the way that you would read this out loud would be f of x equals 3x plus 2. When you've got the variable outside the parentheses, like we have here, right? Normally when we multiply variables together, we just write them side by side, right? xy, ab, mn, that kind of thing. When they're separated with parentheses like this, that's how you know it's a function. So f of x equals 3x plus 2. That's how a mathematician would read this out loud. And if we break it down into its different components, f, the letter outside the parentheses, that's the name of the function. Nice to meet you, function f. The thing inside the parentheses is the input, right? I said there's input and output. So whatever's inside the parentheses, that's where the input goes. And the thing on the right side is the machine that generates the output, right? So the right side is going to be the output that you get, right? Ignore that last part. That last part's kind of confusing. So let's do some basic examples before we get into more complicated things. Okay. So let's say they wanted us to solve for f of 5. Here's how functions work. And I'm going to say this in my delightful Canadian accent to make it easier to remember. When in doubt, substitute. That is pretty much what you're always going to be doing on function questions. They're almost always substitution. Whatever is in the input spot, right, the x, that's the input, gets substituted into the right side wherever you see that same thing. So f of 5 is going to be 3 times 5 plus 2. All we're doing is taking the 5 and we're subbing it in for x. That's it. Okay, and if we finish that up, 15 plus 2, so that's going to be 17. What about f of 8? How would you solve for f of 8? Following those same steps, what would you do? we'd sub it in. That would just 3 times 8 plus 2, which is indeed 26. Okay. How about f of 4? What would f of 4 be? Three times 4 plus 2. Yep. So f of 4 would be 14. The vast majority of functions, that's all you're doing. Like I said at the beginning of class, right? These have a very, very high psych-out factor. They're very intimidating. Because a lot of people look at this and like, I just have no idea what that means. I've never seen anything like that before in my life. GED, how do you expect me to know how to deal with that? But once you do understand how to deal with these, they're really not as bad as you think. They really are almost always about some kind of substitution. Okay? So there are some examples. Let's turn you loose on an actual question. Chimney sweep charges $25 for a chimney inspection. If the customer purchases additional service, $15 of the inspection fee is deducted. There's a flat fee, but if you buy add-ons, they reduce the fee by $15. Let S represent the cost of additional services. Okay, so we know we're going to get some algebra. S is the additional services. And then they actually give us the equation, right? The total cost C of an inspection and services can be determined by this function. C of S is 25 plus S minus 15, where S is greater than 0. So at the end of the day, the first few sentences help us understand the function, but they're not making us create the function on our own. They give it to us. And then the actual question itself, Jan has her chimney inspected and purchases a smoke guard. So that's her add-on for $89. How much will she be charged? So a very long word problem, but at the end of the day, this question is really just asking, if C of S equals 25 plus S minus 15, what's the value of C of S when S equals 89? Right? Just like f of x, we plugged in for x. C of s, we're going to sub in for s. So that's the math we need to do in this one. Now, we can simplify that if we want to, right? Or you can leave it as is, right? But all we're doing is subbing in 89 for s, right? That's what a function is. You substitute the input to generate the output. And now it's just about doing the math. You can use your calculator. You can do it in your head if you're comfortable doing so. But 25 plus 74, 99 bucks. Answer choice A. Okay. So really, this question is really asking, right? Here's the simplified question. If C of S equals 25 plus S minus 15, and S equals 89, what's C? That's what we're being asked to solve for. What is C of 89? Right, that's it. And turning the word problem into the math is the tricky part. But once you know that functions are just substitution, the math itself, not that tricky at all. Like a lot of GED questions, if you know how to do it, you're golden. But if you don't know how to do it, kind of screwed, right? So another good question, if you read it and your brain feels like it's about to explode, guess, spend your time on other questions. If you read it and you understand it, you're not that far away from getting it. It's 89, right? Because we're told up here, S represents the cost of additional services, and that's the additional thing that she bought. Right? So S is additional services. She purchased a smoke guard, an additional service, for $89. So in this case, That's what we sub in for S. Very nice work in today's session, everybody. There's some more practice questions for functions. Questions 8, questions 9, questions 10. Those are great reinforcement questions. Remember, when you scroll down through the PDF, the top half of the PDF is just the questions, just the slides. But if you scroll down, the bottom half of the PDF also has the answers to the questions. So the questions we didn't do together, do those on your own, right, for some extra practice. Before we go, let's just take a quick look at what's coming up next. Let's check out the schedule. So let's see, what do we got coming up? Let's make that a little bigger. Today is December the 18th. So coming up, we got lots of stuff next week. Sunday night, I think it's actually me teaching again on Sunday night. Sunday night, we've got a couple of social studies classes. Geometry next Monday. And some RLA Tuesday the 23rd. And you can always check that out just by clicking up here on your homepage. Glad to hear it, Miriam. Thank you all for a great class. Got any questions for us? Let us know. Also, remember, you can always email us if you have questions between classes. You can always email us at gedhelp@kaplan.com. Thanks to all of you for your participation. Thank you, Sasha, for all of your assistance and doing a great job answering those questions. But we are officially done for the evening. Fly, be free. Enjoy the rest of your Thursday. You are all very, very welcome.